Yeah, hello folks, welcome to my YouTube channel. So today let's try to solve a very interesting question on Leetcode, that is longest increasing subsequence to. Now it is a quite a hard question on Leetcode, and it is based upon the principles of dynamic programming, and for optimization we will be using segment trees. Now I'm picking this problem because it would cover various important topics, and it would pave the path for solving more complex questions related to these topics, right? So let's go by the problem statement. So we are being given an array of nums and an integer k. Now we have to find the longest increasing subsequence of nums which meets our following criteria. The subsequence is strictly increasing, and the difference between the adjacent element in the subsequence is at most k. uh, Fine. As we know, a subsequence is basically an array which is derived from its parent array by removing one or more elements from the parent array. Now in a subsequence, now a subsequence cannot be formed if we interchange some positions of the parent array and construct and try to construct its subsequence. So what I mean by this is, let's say we have an array 1, 2 and 3. So valid subsequence for it is 2, 3, then 1 and 3. However, these are valid subsequence, fine. However, if you consider 3 and 1, this is not a valid subsequence, as we cannot form 3 and 1 by just deleting one or more element from the parent array. To form 3 and 1, we have to replace 3, interchange, swap 3 and 1. However, we are not allowed to do this in a subsequence, correct? So let's try to analyze the how we have derived the first example. That is, we are being having a nums uh, which is given and as per this array, and we are being given a k of 3, correct? Now we have to find the longest LIS following these criteria. Now if you go by the example in the explanation, you would see that the valid answer is 1, 3, 4, 5 and 8. I have represented those elements as star in this thing. Now if you see why this is a valid answer is, the difference between the consecutive elements is at most 3, and the array elements are strictly increasing order, fine. So if you calculate the difference between 5 and 8, 8 and 5, it is 3. Between 5 and 4, it is 1. Between again 4 and 3, it is again 1, which is less than 3. And between 3 and 1, it's again 2, which is again less than 3. So the valid answer is 1, 3, 4, 5 and 8. Cool. So and the length of this array is 5. Now if you similarly see the second example, that is 7, 4, 5, 1, 8, 12, this array, it's again we have been given k as 5, and if you similarly dry run it would be coming as 4, and it is the longest increasing sequence. Similarly for the nums2, it is with k as 1, we would be just having the maximum length as 1, because we cannot consider both 1 and 5, because the difference would be 4, which is less than k, which is more than k, right? Now one thing to observe here is that we are being given the nums of length size as 10 to the power of 5, correct? And if we go via the typical method to find the longest increasing subsequence, so that basically runs in order of n squared time, right? However, we are not supposed to, or we cannot do order of n square algorithm, because it would basically timed out. It would basically be in a timeout with the array of length 10 to the power of 5, and also we cannot have so much space to accommodate 10 to the power 5 into cross 10 to the power 5 matrix. So we must think of some better approach so as to solve this problem, right? So yes, so let's try to think whether we can optimize the order of n square algorithm to something much more optimized, maybe in order of n log n or order of n, right? Now let's alright, so I am just copying this example in whiteboard so that it might be easier to explain. So yeah, all right. So if you see here, so as per this, what is the first element we have? We have to consider it is basically 4, right? Now when we have chosen the first element 4, how many I mean, what are the valid elements we can choose? We can choose 3, we can choose 2, we can choose 1, right? However, because k is 3, so we can choose from uh, up till 4 minus k, that is 1, right? Now when we are at 2, which elements can we choose? We can basically choose 1, and we cannot choose negative as per the conditions in the problem statement. If you see, it's always greater than equal to 1, right? So we cannot choose a negative because it would be not present in our initial given array itself, so that would not form a subsequence. So for 2, what we can choose is it's just 1, right? Now similarly for the second index 1, what can we choose? We cannot basically choose anything, right? Because 1 minus 1 is 0, and we cannot choose anything lesser than 1. Fine. Now for this 4, what can we choose? Similarly, we can choose 3, 2, sorry. Yeah, I have some issues with my writing pad. It seems. Okay, it's not even writing for some reason. Not sure what happened, but yeah. Let's try to change the. I think there's some issue with Jamboard maybe. Alright, let's try to open some different IDs for it. Yeah, I'm able to write here. Maybe it's some issues with Jamboard. Let's try to refresh. I hope I'm able to write it. No, still. So yeah, now we can. Alright. Sorry for the. Alright, so for this 4 at index 3, what can we choose? We can choose similarly 3, 2, and 1, right? Now when we are at the first index, that is this 4, we were able to choose 3, 2, and 1, right? And we have to choose this from the left side of this array, right? So does 3, 2, or 1 exist to the left of the array? The answer is obviously no. So what is the length? If we consider this 4 alone, it's just 1, right? Because I can only choose that 4. I cannot include that 4 with any of the previous elements because those are not even there in the array. Got it? Now when we are at 2, that is index 1, I'm considering zero-based indexing. What is the maximum length we can form? We can only choose 1, but 1 is not there to the left of my 2. So we can only form a maximum length of 1 with this, right? Now again see, when we are at index 3, when we are at index 2, that is the value was 1, we cannot choose any element, so again in this case the maximum length is 1. Alright, now when we are at 4, that is this index, let's change the color a bit, that is this index, what is our maximum length? Our maximum, okay, before that, which elements we can choose? We can basically choose 3, 2, 1, right? Now from this range, which elements we would be choosing? We would be basically choosing the elements which is having the maximum, which could basically form a maximum length, right? Now if we see the element 3 and try to look towards its left, that is by left I mean that is left from the 4, fine. So do we have 3 towards the left of 4? No, we don't have. Do we have 2 towards the left of 4? Yes, we do have 2 towards the left of 4. Alright, now what is the maximum length if we include 2? Now if you see from this part, that including 2 we are able to form a length of 1, right? So if you happen to include 2 with this 4, what would be the maximum length? It would be basically previous one plus 1 contributed due to this 4, right? So my current maximum result would be 2, fine. Now comes the next element. How can we how much would be the length if we include this one in my array? Again the answer is same. We would be looking towards the left of 4 and try to see what was the maximum length formed by 1. Again if you see, it is just 1. So similarly it again remains 2 only and no change in this, fine. Alright, now let's come to the next element, which is 3. That is let's consider this 3 for now, fine. Now for this 3, again similarly what elements can we choose? We can choose 1, we can choose 2 and 1, right? Now if you again see, with 2 we have already formed an element of 1, with 1 again we have formed a maximum length as 1. So if we include 3 along with that, we will be able to just form a length of 2, and this makes and we will be just tracking all these maximum lengths which are formed by each and every individual elements, so that it could be used in future steps, right? So by this point you are able to somewhat estimate that this is somewhat we are storing the state of previous elements and using it in the future, right? So it somewhat makes sense, or in somewhat in principle of the dynamic programming approach which we are following. Now let's go with the next element, that is 4. Now now in this 4, which element we are considering? We are basically considering this 4, fine. Now similarly, which elements can be included in this 4? We can include 3, 2 and 1. Got it. Now if you see this 3, what is the maximum length if I include 3? It is 2. Now where I have got this 2? I have just got this 2 in my previous step, right? Now what is the maximum length if I include 2, or what is the maximum length which has 2 at the last? If you see, it is just 1, as we have calculated in this step, and there was no further 2 in the later on stages, so that it could be updated, right? So if we have 2, it is just 1. If we have 1, it is again 1. That is, we have gotten that from this state. Now what is the maximum out of all these 3? Yes, it is 2, if we include the element 3, right? Now if we include 4 with it, it would be simply 2 plus 1, that is a length of 3. Got it? So this is my answer. If we this is the maximum length if we consider up till this part of the array. Fine. Similarly, we can dry run it towards the other elements of the array. You can dry run it in so as to just get a understanding of it, but I would just leave that to you, and let's just proceed with the examples further. Fine. Now let's see. Now there are few approaches how we can find the elements which was occurring previously towards it, right? So what was happening is, let's consider 4. Okay. Now in 4 we were finding 3, 2 and 1. Got it? Now how can we find this 3, 2 and 1 in this array? One obvious approach is to have a map which would contain how many, how many ones we what was the length, maximum length with 3, what was the maximum length with 2, what was the maximum length with 1, right? So initially this would be my array, and when I am considering 4, I would check what was the value of this when which was ending at 3, 2 or 1. Now for all this the answer is 0, so this 4 would be 1. I mean the maximum including the 4 would be 1. Fine. Now when I am at 2, similarly I would be checking for the array 1. So similarly, my map would my map would basically, okay, now my map would be updated to 4 and 1, right? But however, if you see in this approach, what we are doing is, for each and every element we are basically checking its previous k element and taking the maximum out of it. Fine. So what would be the runtime complexity for it? It would be simply order of n times k times yes, it would be simply order of n times k, because if you consider an unordered map, the search and insert operation is asymptotically order of 1, right? However, if you see the constraint of k in this problem, it is again 10 to the power 5. So, and we cannot make the solution passed with this 10 to the power 10 algorithm because it's quite large. So we must think of some optimized approach, right? Now if you observe carefully, what we were doing essentially is, let's consider this example again. For each element x, yeah, it's a bit complex question, so I'll just try to understand it properly. For each and every element x, we were trying to find the maximum of x minus 1, x minus 2, x minus k, right? I mean, we were trying to find the maximum length which could be formed by having the last element as x minus 1 or x minus 2 or x minus 3, and we were just adding a plus 1 to it, including the element x, right? Now if you see this thing, this entire maximum is a range, right? That is a range from x minus 1 from x minus k up till x minus 1. Got it? Now if we look at here, there are ways we can calculate this thing much more efficiently, right? Now we can use a segmented tree so as to calculate this range effectively, because if we are able to calculate this range effectively, it would solve most of our problem and in order of log n time. Correct. Now let's see how we can use the segment tree for it. So let's consider this given example only. Now for this we would be maintaining a segment tree of the values of the array. Okay. Now what I mean by that is, let's consider a segmented tree which is represented by an array, which would be let's just index it. Yeah. Alright, now when 4 comes, which range so initially all these are 0, value 0, because nothing has been inserted at the very first. Now when I am at 4, what I will be doing is, and case 3, I will be querying this particular range of this segment. So what is the value of it? It is basically from query from the range of 1 to 3. What is the maximum out of it? It is 0. Alright. Now the maximum is 0, and if I include 4 with it, it would be just 1. Got it. Now the next element comes as 2. When I am at 2, I would be querying only this. Fine. Now what is the maximum of just range 1? It is 0. And if we happen to include 2 with it, the length of 2 would be 1. And my subsequence would be just 2. Fine. Now when 1 again comes, I cannot include 1, I cannot append 1 in, at the back of any 1. So for 1 also it would be just 1. Fine. Now when I am at again 4, you see that we have already encountered all these elements. Got it. When I have encountered all these elements, I can basically include them with my 4. Makes sense? Makes sense? Yeah. So with 4, how much range I can query? I can again similarly query range 1 to 3. Got it. Now if you see in the first query, it was all 0 when there was first 4, but now my maximum is 1. Right. This is 3 is 0. So what would be my answer for what would be my answer if I happen to calculate 4 now? It would be 2, because maximum of 1 and 2 is 1 plus 1 by including this 4. Makes sense? So my 4 would be now changed to 2. Fine. And my maximum result would be, which is the global result, would be 2. Now when I am facing 3 again, similarly like 4, I can query in between these two ranges, because 3 minus 3 is 0, but we have to choose 1 from 1, because the least element in the array is 1, right? So I will be basically querying from 3 minus 1 to 3 minus 3, that is from 1 to 2. What is the maximum from 1 to 2? It is 1. If we include 3, what it would be? It would be just 2. Now our global maximum does not change, because previously we have encountered 2 and now also it is again 2. Fine. Now let's see when there is a next 4. Now when we are at 4, we can basically query in this range. Makes sense? So let's see what is there in this range. That is from 1 to 3. If you see from 1 to 3, that is this range. What is the maximum? The maximum is 2 if we include 3 before 4. Alright. Now if we include 3 before 4, what would be the length of it then? 2 plus 1, that is 3. Now why we are considering 2 plus 1? 2 because of this maximum range's value, and 1 because we are including this 4. Makes sense? So this is 3 now. Now what is our maximum? It has been changed to 3. Got it? So basically this would be our overall approach, uh, uh, and if we happen to calculate it throughout the length of the array, we would be basically having our answer as the maximum global value which we have obtained by inserting and updating our ranges in the segment tree. Now if you see, for each element x, how much range we are querying? We are basically querying the range from x minus 1 till from x minus k till x minus 1, right? So this is the range we are querying. And what is the time complexity of querying in a segment tree? It is basically log of n, or the log of the length of the segment, you can think it of. Got it? uh, so few more things to consider is how we are updating the segment tree. Now let's say the element 4 comes. Fine, we would at first query the range from 1 to 3. We were getting the maximum, and then we were updating the 1 at the index 4. Fine. So let's go by the example only. Let's say yeah, so let's say uh, we have inserted 1, 2 and 4. Fine, there is the first 3 elements. Now when the next 4 comes, okay, let's start from the first only. Yeah, so let's say when the first 4 comes, I don't have anything in this range, correct? The maximum is 0. Now we have to insert maximum is 0 and the value for 4 is 1. So after doing the query in this range, we will be updating the value at this range, at this point. So it is basically point index in the segment tree. Makes sense? So I would be updating just this point as 1. I would be covering the code in a subsequent video, because this video has already been quite long, around 30 minutes. So just for the clarity of the code and for concise video, I would be doing that in the next videos, in subsequent videos, which will be coming maybe tomorrow only. Now for this element 2, at first we will be querying this range, that is from 1 to 1, value is 0. If we include 2, it's the maximum result we could form is 1. So we would be doing a point update at index 2, right? Similarly for 1, it would be a point update in index 2. Now for this 4, at first we will be querying this, we will be getting a maximum of as 1. If we include this 4, since it is just addition of 1 element, my resultant answer would be 2. Fine. So again we will be doing a point update here at 2 as 2, and we will be just maintaining a global answer. We will be updating accordingly whenever we encounter a subsequent mode element. So initially we could initialize just a global maximum variable as 0. Whenever we encounter some different value or mode value, we will be changing our global maximum. So if we use this segment tree, we can reduce the time complexity of this problem to order of n log n, which is pretty good to pass the algorithm owing to the constraints which we have, right? So let's have this video up till this point. I would be covering the code implementation in the subsequent videos later on. Thank you.